Hello everyone. Today my name is Christian Fahzy Benayun, and today I will doing a presentation about AC current motor. And for introduction is the AC current motor is some of the most famous invention made by Nikola Tesla in 1887, which is changing the world we know right now. This invention is popular among industrial part and we can find it anywhere, even for even from factory until the workshop. Then we will explaining about basic of AC current motor, which is measuring the rotating speed, torsion, and the induction motor, which come from working principle, construction, loss and efficiency, also rotation and induction motor, and the torsion characteristic of induction motor. First of all, we start in basic. On measuring rotation speed, we use the tachometer. The rotating speed is counted with unit of RPM, and the measurement is used using tachometer and aim it on the center of the motor. And the torsion, it's come from the force and length. This is the formula of torsion and moment. The force produced for electric motor come from interaction between rotating magnet wave on the stator with induction wave from rotor. Number of winding on the rotor set and polyrotor is air matter. So torsion produced by motor is M, which is P time L time L time Z time R. And the relationship between torsion velocity and power, which is P is moment divided by T, where moment is come from force time L. And the power, which is come from F force time L per T, and velocity is come from L per T. Well, on rotation distance travel, the formula is L, which is 2 time R time P, and the velocity, which N time 2 time R time P. With adding force on F, which happen in the axis, we getting an equation which N time 2 time R time P and time F, which is force. So in the end, we getting the relationship of power motor P with axis torsion M with equation. We know P, which is 2 time P time N time M. P power from unit, which Newton meter per minute used if M torsion measured using Nm unit on the power, which P equal with 2P divided by 60 times 100 Newton per meter, where Newton per meter per second is equal with 1 kilowatt. The last equation of power and torsion M, practically P equal with Newton point M divided by 9,547 kilowatt. Now for the induction motor. Induction motor working principle, which come from transforming the electrical energy into mechanical energy, which the electric transform in three phase. Induction motor is often called asynchronous motor. The induction motor working principle come when the base U voltage enter the stator winding, it creates the S south pole. The magnetic field line flow through the stator, while the other two poles are N, which is north for phase V and V. Then W, I mean. The compass will be attracted to the S pole. Next, the S pole moves to the phase V. The compass rotates 120 degrees, then the S pole moves to the phase V, creating a rotating magnetic field in the stator winding. The evidence is that the compass will rotate again 240 degrees. The event occurs alternately, forming a rotating magnetic field, causing the compass to rotate in a full turn. This process continues uninterrupted. In an induction motor, the compass is replaced by a squirrel cage motor that will rotate on its axis, because there is a difference in rotation between the stator's rotating field and the rotor station. It is called a non-synchronous induction motor or a synchronous motor. From the four conditions above at angle 0 degree, 120 degree, 214 degree, and 360 degree, it can be explained that a rotating field is formed in the stator, and the rotating magnetic field of the stator will cut through the rotor winding. The speed of the stator rotating magnetic field is often referred to as synchronous speed, which cannot be measured with instrument, but can be theoretically calculated with this formula. And S equal to F times 120 divided by B. The rotor is placed inside the stator cavity, so the rotating magnetic field line of the stator will cut through the rotor winding. The rotor of an induction motor consists of several conductor powers and are short-circuited, resembling a squirrel cage. This even causes electromagnetic induction to occur in the rotor. The rotating magnetic field from the stator interacts with the rotor magnetic field, resulting in torque U that causes the rotor to spin. And this formula, the speed of rotating magnetic field on the stator, which comes from Ns equal to F times 120 divided by the unit used is RPM, and the slip, which Ns minus Nr divided by Ns equal with 100%. The description of the formula can be seen below. And now we come to the construction of electric motor, which come from van cover, van, bearing, eye-bolt, nameplate, frame, rotor, and shield, drain plugs, stator, terminal box, stator winding, shaft, and V-ring slider. And the detailed construction of an induction motor consists of two parts, namely the stator and the rotor. This part is main important. And the stator is stationary part of the motor consisting of motor body, stator core, stator winding, bearing, and terminal box. The rotor part is the part of the motor that rotates, consisting of the squirrel cage rotor and rotor shaft. Formula for calculating the input power of an induction motor, which P1 divided by root 3 times U and cos theta. The unit used is watt. And this is the description of the formula. Next, we go to the loss and efficiency of induction motor. Electric motor have a loss which happen because electric motor itself has copper resistance component from stator winding, stator, and inductor component. In an induction motor, there are copper losses, core losses, losses due to friction and wind resistance. The equation from losses in the induction motor, which come to P1 minus P2, the equation can be seen below. And the calculating of torsion, which can be seen below with the description. Now for induction motor rotation. Induction motor have two rotation which clockwise and counterclockwise, depend on its pole and circuit. Commonly two-pole induction motor have axial rotation of 2950 rpm, while the four-pole have 1450 rpm. The clockwise rotation, which is right, is achieved by connecting L1 terminal U, L2 to terminal V, and L3 to terminal W. CCV or counterclockwise rotation, which is go to left, is achieved by swapping one of the two base cable, for example L1 terminal to U and L2 terminal to W and L3 terminal to V. By installing two contactors, an induction motor can be controlled to rotate clockwise and counterclockwise. A practical application for opening and closing a garage door with an induction motor can utilize this clockwise and counterclockwise rotation principle. By equipping it with a lag sensor or manual switch, the motor can be activated to open and close the garage door. And characteristic of motor torsion, we can see it from here. And the torque characteristic of induction motor is called the torque as a function of slip. The vertical line represents the torque parameter, which comes from 0 until 100%, and the horizontal line represents the slip parameter, which 1.0 until 0.0. There are four known types of torque, namely 1 ma, initial torque moment, 2 ms, pull-up torque moment, mk, maximum torque moment, and p, working torque moment. Torque characteristic can also be present in another form. We know the rotational characteristic, its torque function, and n equate f, aka torque. The vertical line showing the rotation parameter while the horizontal line showing the torque parameter. When the motor rotates at line N, the torque is obtained at point M. When the rotation is at Nn, the motor torque is at Mn. The operating range of the induction motor rotation is in the area N and Nn. So the operation torque of the induction motor is also in the area M and Mn based on the graph N, which is function called as torque. It can also be concluded that when the rotor's rotation decreases from N to Nn, the torque actually increases from M to Mn. And the other characteristic of the induction motor can be seen on the figure 1.15, which include efficiency parameter, duty factor, current ratio, and speed ratio. By reading the characteristic of the induction motor, its required parameter can be determined. When the torque reaches 100%, the current ratio L per LO can be read as 1, the power factor cos theta, 0.8 motor efficiency, 0.85, and the speed ratio N per NS, which is 0.92. That's all my presentation about AC current motor. Thank you and goodbye.